In this tutorial, we're going to talk about our first two major theorems that talk about triangle congruency. The first one is shorthanded as SSS, and all that stands for is side, side, side. And what this says is if you have your three corresponding pairs of sides of two triangles, they're automatically congruent. And this is postulate 4.1. This is on page 205 if you want to check it out. But this is going to be very, very helpful, especially when we start our next set of proofs, because you're going to get a lot of things that look like this. So in this example, it's kind of proof-based. We are given this picture, and it says the given information, besides what's written here, I know that GF is congruent to KJ because they both have two tick marks, and that HF and HJ are also congruent. So the only pair of corresponding sides that we have to make sure that are congruent are GH and KH. And just by looking at the given information, it says H is the midpoint of GK. And because I know that midpoint means that it is a point directly in the middle, I know because of the definition of midpoint that this segment is congruent to this segment. So look at what we're trying to prove. We're trying to prove that triangle GFH is congruent to triangle KJH. Well, have I proven that? And the answer is yes, I have. And my main reason here is because of SSS, because of side, side, side. It's because of that theorem. So that's how that works. It's pretty straightforward for side, side, side. And the other theorem or postulate that we're going to learn is SAS, which represents side, angle, side. So in order to use side, angle, side, that means that this side must be touching this angle and that must be touching this side. So it kind of has to be, well, it doesn't kind of, it has to be in an order like that. So look at triangle ABC. So an example of the way that this would look like is, let's say I start with this piece. This would be my side. And I'm going to go clockwise around this triangle. So side, and then angle, and then side. Notice that all three of those touch each other. They're all one family. They're not spread around the triangle. They're right in order. So this would represent a side, angle, side situation. Another situation could be if I start here at this side. And maybe I'm still going in a clockwise direction. So side, angle, side. What you can't do, look over here at the other triangle, triangle DEF. What I can't do is side, angle, side. That it does not back up this theorem, because this is saying that they have to all be touching each other, and this side, this DF business, isn't touching anything else that I have. So we can't use that. So what I'm looking for is something along these lines. So I would say segment CB and DE are congruent, angle B and angle E are congruent, and then segment BA and EF are congruent. And my congruency statement would look like this. Triangle ABC is congruent to triangle FED by side, angle, side. And that's how that theorem works. And of course, you're going to see some problems that have you name different parts. And once you know all these parts are congruent, then all the sides should be congruent too. So you could even take this a step farther and say if CB up here was 2x and DE was 18, then I could set up an equation after I know that the triangles are congruent. And I could say that 2x is equal to 18, divide both sides by 2, and then x would be equal to 9. So you can see if you can foresee some problems like this where you're going to have to determine angle measures or missing variables, but it's all built on showing first that the triangles are congruent by side, angle, side, or side, side, side. And that concludes this tutorial.